Okay, so we have this rule right here. Now notice how we were given the legs each and every time. Formatting error, this 7 was supposed to be here. What if we're given the hypotenuse and we have to find both legs? All right, so we have a squared plus b squared equals c squared. But remember, both these legs are the same. So I'm just going to call them both x. Or I could call them both a or both w or both j. But really, to find the lengths of the legs, now I'm just going to do x squared plus x squared equals 7 squared. So x squared plus, remember x squared plus x squared equals 2x squared. And then that's 49. Then you divide by 2. X squared equals 49 over 2. Take the square root of both sides. You're going to get x equals the square root of 49 over 2, which breaks up into radical 49, radical 2, or 7 radical 2. I'll pause there really fast, or for a moment I should say, because I was going really fast. Alright, so x squared plus x squared is 2x squared. Divide by 2, then do the square root, simplify. Now remember, we got to rationalize the denominator. We don't like this radical 2 right here. We don't consider that simplified. So I'm going to multiply both numerator and denominator by radical 2. So my final answer will be 7 radical 2 over 2. And boom, that's it. So both legs were 7 radical 2 over 2. 7 radical 2 over 2. There is another pattern going on. All right, this pattern, it's slightly more difficult. You might already be onto it. Let's see, we're just going to do a few more problems and see if we can figure it out. All right, let's find the legs over here now. All right, so remember, this is the hypotenuse. Let's mix it up. Let's call this J. We haven't used J in a while. All right, so J squared plus J squared equals 20 squared. All right, so we get 2J squared equals 400. Ooh, we got an even number this time, so when we divide by 2, we won't be left with any silly fraction. All right, so J squared equals 200. Take the square root of both sides. Ooh, I won't have to rationalize the denominator or anything. What's the largest square factor of 200? 100. All right, so J equals 10 radical 2. 10 radical 2. Now, how does that relate to 20? All right, so other one we had 7 and 7 radical 2 over 2. This time we had 20 and 10 radical 2. A little bit more harder. This one, ooh, let's look at number C. All right, let's call the legs Q this time. All right, where do I want to write this? Let's just start right here. And this is the hypotenuse kind of floating out in space. Q squared plus Q squared equals 4 radical 2. Put the whole thing in parentheses. 2Q squared. So when I have this, the 4 needs squared and the radical 2 needs squared. So simplifying this right hand side, we're going to have 16 times 2. So 2Q squared is going to equal 32. That was a lot of math. And we're not even done yet. Now I got to divide both sides by 2. And Q squared equals 16. Take the square root of both sides. The square root of 16, Q equals 4. Intense math going on right now. Also, I want to take time to realize that I'm making this video on May 4th. May the 4th be with you. Star Wars Day. One of the most important days of the year to me. I love Star Wars. All right, back to math. No more talking about Star Wars. We got to focus. We got 8. Let's see. What should we call this? V and V. So I'm going to have v squared plus v squared equals 8 squared. 2v squared equals 64. Divide both sides by 2. V equals 32. Take the square root of both sides. V equals the square root of 16 times the square root of 2, or V equals 4 radical 2. All right, we've done a wide variety of problems. We had a hypotenuse that was odd, an odd number in 7, two hypotenuses that were even numbers. We had a hypotenuse that was 4 radical 2. We were kind of all over the place. You might have realized a pattern. If you did, pat yourself on the back. If you didn't, don't worry. I'm going to explain it right here. This is it. This is the pattern. This is the punchline. All right. If we have some... Let's see. I didn't do a good job of drawing my right triangle. All right. If the hypotenuse is x, the legs are going to be x radical 2 over 2. That's the pattern, is you're multiplying by radical 2 and dividing by 2. Now there's two ways to describe this, all right? You can say that, or you can just say x over radical 2. Because sometimes it's easier just to say you're dividing by radical 2, such as in this example right here, where we had 4 radical 2. Well, we just had to divide the 4, or we divide radical 2 and you're left with 4. All right. In another example, that's when dividing by radical 2. Realize these are the same rules. It's just a rationalized denominator. Let's rewrite this. These are the same. This just has a This has a rationalized denominator. And we spent a whole day talking about that. We'll just write denominator like that. I don't feel like I've ran out of room to write it. All right. Over here, though, with 8, so I'll write 8 here. It's like multiplying by radical 2 and dividing by 2, and you just do 4 divided by 2, or 8 divided by 2, and you're left with 4 radical 2. So it's the same thing, just presented differently. So legs in this down here equals the hypotenuse times radical 2 over 2, or legs equals hypotenuse divided by radical 2. The same rule, just presented differently. All right, so look at all these calculations. We've done a lot of math in these first 2 videos. In this next video, we're really going to do minimal calculations. All right, we're going to fly through these problems. We're going to apply the rules, and boom, we're going to nail them.